Hi folks, welcome back to 7.5 part 3. And in this video, we're going to continue looking at linear equations and looking at the family of linear equations for trigonometric equations as well. All right, so let's get started. We're going to take a look at 6a and 6b. And one of the things I want us to notice is that 6a is just 2x plus root 2 equals 0. But 6b is just 2 times root 3x plus root 2 equals 0. And so the things that I've highlighted in the yellow actually look, if I sort of blur my eyes a little bit, it makes the rest of the equation look very similar. In fact, we could even preview this and look down at 6c and notice again, 2 times something plus root 2 equals 0. All right, so that's the pattern we're looking at here. All right, so let's get started with 6a. I want to solve for x. First thing I'm going to do is subtract root 2 from both sides. So I'll get 2x equals negative root 2. Next step, I'm going to go ahead and divide both sides by 2. So I'll get x equals negative root 2 over 2. Now, I'm only looking for x. That is the thing that was in the highlighted yellow. So this is the end of the road, and that is the answer to this question. All right. Now, we want to make sure we're leaving things in exact form here. So we don't want to turn this into a decimal. We want to leave it as it is. All right. On to 6b. All right. First step, I'm going to be the same. Subtract that root 2. But now I have 2 root 3x equals negative root 2. Next step, I'm going to divide by 2. Root 3x equals negative root 2 over 2. Now, I need to think about how I can get the x out of the square root. And so what I'm going to do now is I'm actually going to square both sides. And when I square both sides, I end up with 3x equals negative 2 over 4, which is really negative 1/2. Okay. Last step, I'm going to divide both sides by 3. I get x equals negative 1 over 6. So in B, I had to go a little bit further because I had square root of 3x. I didn't just have the x there. Okay. Now, if some of you are wondering how I got from here to here, I'll just do that off to the side. So negative root 2 over 2. Oh, shoot. And I caught a mistake while I was doing this. And I square it. I'm going to end up with a negative times a negative is actually going to be positive. So let's go ahead and make this positive right here. And square root of 2 squared is 2. And the denominator, 2, when I square that, I get 4. All right, so that's how I get that 2 over 4 here, which I go ahead and reduce to the 1/2. All right. So we're going to follow something pretty similar to do 6c. All right, but this time, instead of having to worry about getting root 3x, we're going to actually have to solve for the theta in this sine 3 theta here. All right, so first step, we're going to go ahead and subtract root 2. Next step, we'll divide by 2. Okay. Now, with these kinds of equations, it's actually easier if we start with the general solution. And what I mean by these kinds of equations is when I have sine of something that's not just theta. All right, so it might be sine of 5 theta or sine of 2 theta, or it could even be cosine of 7 theta, something where it's not just theta. Okay, in these cases, I'm going to suggest that we go ahead and do this first. Okay. So I'm going to take what we have here. We're going to go ahead and just slide this right over. All right. And we're going to work through our general solutions. All right. Now, we've done this before. We've done sort of a substitution, and we're going to do the same thing here. All right, we're going to let u equal 3 theta. All right, then we have the following. We have sine u equals negative root 2 over 2. Now, we know from our unit circle, that means that u will be, let's see, where is the y value equal to negative root 2 over 2? That's going to be 5 pi over 4. And, oops, plus 2 pi k. And u will equal 7 pi over 4 plus 2 pi k. All right, and in both cases, k is an integer. All right, now that solves for u, but it doesn't solve for our 3 theta. So we got to go back to here. Everywhere we see a u, we're going to replace it with a 3 theta. Okay, turn it back into blue. That means I get 3 theta equals 5 pi over 4 plus 2 pi k. But I want theta. I don't want 3 theta. So I'm going to go ahead and divide both sides by 3. Theta equals 5 pi over 12 plus 2 pi k over 3, where k is an integer. Okay, that's for the first solution. Now let's do the same thing with the second solution. 3 theta equals 7 pi over 4 plus 2 pi k, and divide everything by 3. I get 7 pi over 12 plus 2 pi k over 3, where k is an integer. All right, so all of this work means that these right here are our general solutions. All right, but now that we have these general solutions, now we can go back and find the solutions that are just one time around the unit circle. Okay, now here's what we're going to do. We're going to start by plugging in numbers for k, and we're going to start by plugging in 0. All right, so one of my solutions is 5 pi over 12 plus 2 pi times 0, which really just leaves me with 5 pi over 12. So that's one of the solutions. Okay, the second one is going to be 5 pi over 12 plus 2 pi times 1. So really, I'm adding 2 pi. I'm going around the circle. Oh, sorry, 2 pi over 3. Goodness. Let's erase these. 2 pi times 0 over 3. 2 pi times 1 over 3. So really, I'm adding 2 pi over 3, right? So 5 pi over 12 plus 2 pi over 3. I got to make a common denominator. So that's going to give me 5 pi over 12 plus, let's see, times 4 is 12. That means 8 pi. So I get 13 pi over 12. All right, that's the second answer. Now I'm going to plug in 2. Theta equals 5 pi over 12 plus 2 pi times 2 over 3. All right, now I'm going to go ahead and combine some steps. I'm going to make a common denominator at the same time. So I'll get 5 pi over 12 plus, see, I want the denominator to be 12. So 4 times 4 is 16 pi, which gives us 21 pi over 12. So I've got 1, 2, 3 solutions from the first one here, right? And let's see if we can maybe highlight these just to make it a little bit easier for us to see. So this general solution gives you this, and this specific solution. Now we need to do the same thing over here with our second one, all right? So I'm going to get theta equals 7 pi over 12. That's going to be one of them. Then theta equals 7 pi over 12 plus 2 pi over 3, because I'm plugging in 1 for k. Let's see, that'll give me 7 pi over 12 plus 8 pi over 12, which is 15 pi over 12. And then theta equals 7 pi over 12 plus 4 pi over 3 is really 7 pi over 12 plus 16 pi over 12, which is, what does that give us? 423 pi over 12. All right. Now, these three specific solutions, those come from the second general solution. Okay. So I know these are pretty long and complicated questions, but a lot of this is the arithmetic, and keeping in mind that we are going to do the general solutions first, okay? So let's go ahead and try 6D and see where that takes us. All right, whoops. First things first, I'm going to add 1 to both sides, and then I'm going to divide by 2. So let's do that over here. That will give me sine of 3 theta. Let's see, I said I was going to add 1 and divide by 2. So add 1, divide by 2. And now I'm going to do my u substitution. So really, I'm thinking sine u equals 1/2. And what do those give us? Then u, where's the y value 1/2? Well, that's going to be pi over 6 plus 2 pi k. And also 5 pi over 6 plus 2 pi k. And all of these are where k is an integer. All right. Now, again, I don't want u. Okay. I want u to be equal to 3 theta so that I can solve for 3 theta. So we're going to put the 3 theta back in to both of our solutions. Oops. 5 pi over 6 plus 2 pi k. And I'm going to divide everything by 3. So pi, oops, theta equals pi over 18 plus 2 pi k over 3. And theta equals 5 pi over 18 plus 2 pi k over 3. And in both cases, k is an integer. All right. Now, like above, I'm going to take the second one and I'm going to plug in some values for k. In fact, I'm going to plug in 0, 1, and 2. Those are going to be the 3 values I plug in. And then same thing over here for the first one, I'm going to plug in 0, 1, and 2 for k. All right, so let's do our arithmetic. Theta equals pi over 18 is one of them. Theta equals pi over 18 plus 2 pi over 3 is really pi over 18 plus, let's see, I want to multiply by 6 this time. So 12 pi over 18, which is 13 pi over 18. And then one last one comes from the purple one. It's pi over 18 plus 4 pi over 3. And so that'll give me pi over 18 plus, multiply by 6, multiply by 6, 25 pi over 18. And these 3, they come from our pi over 18 one, okay? Now we got to do the same thing over here with the yellow ones. So theta equals 5 pi over 18 is going to be one of them. And then theta equals 5 pi over 18 plus 12 pi over 18, which is 17 pi over 18. And then last but not least, 5 pi over 18 plus 24 pi over 18 is 29 pi over 18. And those three come from that yellow one, okay? So these are some examples of sort of that more complicated case where we have to actually start with our general solution, all right? Now, opportunities for extra credit, if you'd like, you can make an appointment with me and talk to me through the process of how you solve 6E and 6F, all right? So I'm looking forward to seeing some of you there. All right, that's going to wrap up this video for the part 3. In the next part, we're going to take a look at some quadratic equations, all right? So come on back and I'll see you there.